Soccer ball is kicked off a cliff with an horizontal velocity of 15 meter per second and an initial vertical velocity of 8 meter per second upward. Okay, let's just draw a rough diagram. So we have someone kicking a ball with horizontal of 15 meter per second and vertical of 8 meter per second. Again, guys, whenever you're getting any opportunity wherein you can draw, please do. Even a rough diagram is good enough. Okay, find the ball's horizontal and vertical velocity just before it hits the ground. So it might go somewhere like this. So this might hit the ground over there. And we can call this as point A. This is point B. And that's point C. Find the ball's horizontal and vertical component of velocity just before it hits the ground. Determine the total speed of the ball just before it hits the ground. Okay, well and good. Find the ball's horizontal and vertical component of velocity just before it hits the ground. I mean, if you find this by default, you will find this. Vertical component will remain the same. Sorry, horizontal component will remain the same. We just have to figure out the vertical component. Okay. So obviously, we have to consider up and right as positive, and thus making this as minus 10. Okay. So point B for me is a point wherein it is in level with A. This also is 20 meter above. That's the point wherein the ball passes the horizontal level. Okay, when it's going down. So that is something that you have to write all of that, right? Here, A is where the point where the object is kicked from. A you need not write actually. Technically, A need not write. B you guys write, describe it. C you guys describe it. Okay. So with that, making that very clear. Actually, if you don't describe it, no, B you have to describe. B would be a better thing to describe. C, it's okay. A, you don't have to. B, you can you have to describe B. That will make more sense to you when you guys yourself reading. C, I think it's okay. In exam, try to write B at least. Because of time constraint, I won't advise to write everything. Okay, so all of this will deal with deal with what the velocity is over here and the journey. That's it. The fall basically. So at B, what happens? The velocity, what will happen to the velocity? Think about it. The vertical component and the horizontal component, what happens to them at B? They'll remain the same as whatever happens at A. So this will be 15 meter per second and that will be 8 meter per second. Because it's pointing downwards, it's minus 8. Okay, as simple as that. We know the velocity, we know the distance. You just have to find the final velocity before it hits the ground and you're done. So let me explain what I'm talking about. Again, guys, by default, you have to pause every question, draw the diagram, then unpause, then check my diagram, then pause again and do step by step. Okay, if I'm not telling, doesn't mean you should not be doing that. So y components the initial velocity along the y at B will be minus 8 meter per second. Then your, what else? The distance it has to travel. So distance to ground would be 20 meters. Then what else do you need? Acceleration due to gravity is 10 meter per second square. That's it. So all we have to do is find the final velocity. V square is equal to u square plus 2as. This works for me. And yeah, s is minus, by the way, because it's pointing downwards. U is 8 8s are 64 minus 2 into, or let me do this, minus 20. Minus because if this is the origin, I'm pointing downwards, and down according to our sign convention is negative. So all this will work out to positive. So V is equal to root of, so that will be 64 plus 40, 400. 464. 21.5. 400, yeah. 21.5 meter per second. So this is the velocity when it hits the ground at point C actually. YC, YC. Okay, so VYC is 21.5. Then finally you can find the resulting velocity. V at C will be equal to, the X will not change, so that will be 15 I cap minus 21.5 J cap. As per this convention, I have taken the sign. And that's that. Next is what? Next is determine the total speed of the ball just before it hits the ground. Ball's horizontal vertical component just before it hits the ground. Okay, actually this was not needed. Anyways, I wrote it. Then we have the speed at C. That will be 15 square plus 21.5 square root of that. So this will be 15 square plus 21.5 square. So root of this particular value will be 26.22 meter per second. Okay, that's it. Right here, I didn't do a lot of calculation. So you can see most of the places we can't use the formula. Please see that now. If you are able to, convince yourself, and if you're able to tell yourself that, you know what, just memorizing the formula is not the way. That's the best thing that can happen to you guys now itself. Because everything that you're going to see will be two-dimensional motion, three-dimensional motion. Three-dimensional motion is less, but yeah, two-dimensional motion and whatever, it might be even three-dimensional, doesn't matter. So the point is, you can solve everything by using just the component form and using simple set of force and work and energy and vectors and equations of motion and so on and so forth. It's that simple. Right? Whatever in the future you'll see, it will be force of some caused by something. And you can use the energy concept, work concept to solve most of it. Right? So work and energy and all of that, then you will not need vectors. But point is, this is it. Simplifying, thinking it component form, part by part, and then using it makes it a lot simpler. Using simple equations, that's it. It's nothing complicated.